In this video, we are talking about the single board diagram, which is important for us, and we will talk about it. So, block diagram of the single board diagram for single board computer human machine interface application equipment. Now, uh, we see that on the basis of this, we have a logic here, we have a clock there, beard interface, POC accessories. In the middle you have application processor, then you have a general purpose processor. This is general purpose processor, and here is a microprocessor. As you know that computers work on the basis of CPU is on the basis of central processing unit, and that is the two type of the processors, like a microprocessor. And so in this general purpose processor you have the microprocessor. The common connectivity is connected with the EMC and SPI USB cable, 12C LCD and UART, external memory and CAN. This also connected with the touch screen, which output to the touch screen monitor. Then they have backlight, the hard drive and power management unit, audio video, then power manager, HS USB transceiver, keypad and battery charger. This diagram shows us that how the single block diagram for the computer is the system power, low noise analog, gas lock, and a C64 DSP core, video oscillator, 2D 3D graphic engine, and then battery charger. So the purpose solution can be used to design equipment that can be equipped, that then can be equipped, and namely is like a, where is eraser? Sorry, I'm trying to find the eraser so I can erase everything. I think is this eraser. Yes, this is the eraser. I'm cut down. So the purpose solution can be used to design equipment that can be function as one of the three industrial applications, namely single board computer, human machine interface panel, also known as operator interface point or service kiosk. The fundamental required to each of these applications is a powerful processor core capable of the superior video processing, graphical performance, producing a wide variety of the highly integrated peripheral options. Processor selection. Knowing processor performance requirement is useful when choosing the TI embedded processor for the industrial applications. Particularly care should be taken, however, to include a realistic estimate to the performance required by the human machine interface, particularly involving video, 2D and 3D graphics. Other considerations such as peripheral mix are also highly relevant. Once a performance requirement is determined, applications are roughly determined down into three categories. For the less than 150 dry stone MCU based on ARM Cortex M3 core provide the best price and performance from 150 to 500 MIPS. MU based on the ARM's 19 core likely the best choice from 500 to 1500 MIPS. MPUs based on the Cortex A8 core are the best for the higher computing requirement. Core subsystem component applications processor, the OEM-AP processor family of the multimedia application processor. This lend to themselves extremely well for these applications as it provides superior computing performance. In addition, the highly integrated peripheral set include many system level components that will be reduce the overall BOM and PCB. Power and performance management technologies like reduce power consumption, dynamically controlling voltage, frequency, and power based on the device activity, modes of operations, and temperature. SBC single board computers, which enable the shortest development time, are the of the self-compact motherboard with the input-output source on board. Because of their power density, low power CPU are almost always used. The targeted OMP performance key features such as Oshitara ARMS processor, which feature powerful ARMS cortex, wide peripherals, shed, open engine connectivity. Now let's know what Wikipedia say about single board computer. Single board computer is a computer that built on a single circuit board with the microprocessor. You can see here, this is the example. This is the example, like you can see, and this is the example. Here you have single processor, and you can use this. This is the Raspberry Pi first model, and it's a low cost single board computer. It's often used to take computer science. So a single board computer is a computer built on a single circuit board with a microprocessor, memory, input, output, and the other features required of a functional computer. Single board computers are commonly made as a demonstration or the development system for educational system or for use of this embedded computer control. Many types of the home computers are portable computer integrated all their functions onto a single printed circuit board. Unlike a desktop personal computer, single board computers often do not rely on expansion slot for the peripheral function or expansion. Single board computers have been built using a wide range of the microprocessor. Simple design such as those built by the computer hobbyist often use static RAM, low cost 32 or 64-bit processor like ARM. Other types such as blade server, which performs simple and server computer on the computer. A computer or module is a type of single board made up plug of carrier board, baseboard, and blackboard system expansion. Single board computer comparison finding best SBC. Advances in single board computers have the dramatically changed in the field of electrical engineering and the maker space. The perfect single board computer for your application is out there. Let us help us find it. What is single board computer? Single board computer is distinguished from a traditional development kit or evaluation board because it is an entire computing platform in a single package. It has all the necessary hardware and software function built right in. For the purpose of the discussion, we expect the single board computer to have the following: an applications processor capable of running a high level operating systems like Linux, Android, or Windows, out of the box functionality, be wired and wireless connectivity, a strong ecosystem of user expansion card, and open source software. What is the best single board computer? There are the many SBCs out there, and each boasts its unique edge. Even engineers that work consistently with the single board computers may find themselves overwhelmed by the expanding market. That is why some single board computer knowledge center resource all the things about single board computers, where we compare, contrast, and evaluate the pro and cons of the single board computers on the market today and keep you informed of what's to come. Features: single board computer. Browse features products from single board computer manufacturers like Raspberry Pi, Intel, and Nvidia. Is our single board computer comparison chart below, so it's best for you. Here you can see that Raspberry Pi 3 Model B. If you see the Raspberry Pi Model 3, you find that Raspberry Pi 3 is a credit card size computer capable to doing anything a desktop PC does. So you can use Raspberry Pi Model B, and this Raspberry Pi 3 is a very uh, credit card size like a computer capable to doing just about anything to desktop PC does. You can also use the GTP PDKV. This is the manufactured by the Intel Embedded System Development Board, and this computer can use in the form of the uh, developer kit expansion board, and you can it is also can use if we truly talk about the specification of single board computers, then we find that there is a processor, CPU type. Your choice are like Intel Atom, trademark Atom. Intel Atom is the smallest processor built with the smallest transistor. In 2010, it is the designed specifically for the mobile internet device and is a simple PC network. General space of the Intel 386 trademark family. Internal registered size 32 bits. Data input output bus within 32-bit memory. Address bus with 24 bits and 32 bits DX series. Maximum memory 16 MB and 4 GB DX series. Intel 386 trademark family. Then you have Intel 486 trademark family. General space of Intel 486 trademark family, like internal registered size 32-bit data input output bus with a 32-bit memory address bus with a 32-bit maximum memory 4 GB. Intel registered platinum registered second. General space of the Intel Platinum family. Internal registered size 32-bit data input output bus with 64 bits memory address bus with 36 bit maximum memory 64-bit GB. Utilize Intel 0.25 micron manufacturing process. High clock speed up to 450 megahertz. Intel Platinum. General space of the Intel Platinum family. Internal register size 32-bit data input output bus with 64-bit memory address bus with 36-bit maximum memory 64 GB. Utilize Intel 0.18 micron manufacturing process. High clock speed over 1 GHz. Intel Platinum 4. This Intel Platinum 4 processor is based on the new Intel NetBus trademark microarchitecture, a powerful processor that is available at speed over 2 GHz. Intel Platinum and Intel microprocessor especially designed for the mobile system. General space of the Intel Keltron family. Internal registered size 32-bit data input output bus memory address bus with 36-bit maximum memory 64 GB. Intel Itanium. The Intel Itanium processor is based on the Itanium microarchitecture. It is designed by the demanding technical observations. So these are the some of the specification input output device storage, and in the next video we will talk about network access device and the input output device storage.